Hello students, today we'll be talking on function return types. As we know that functions are independent blocks of code and they receive the data from the calling function, and that data, that is actual arguments which are received in formal argument, is processed within the function, and function computes the results, and these results are called as return values. Now the data type of the result that is computed is what we call as return types. Now functions can be classified into two types based on the return values. There are functions which don't return the values, and there are functions which return a value. Now functions which do not return a value are called as void functions. Now functions can return the values of different data types. These data types can be primitive or user defined data types, and among derived data types usually pointers. The return values are specified in the return statement. So the return statement is used to specify the return value. The function can contain multiple return statements. It's not obligatory that a function, or necessary that the function will contain only one return statement. It can contain multiple return statement in case it returns a value. The first return statement that is executed in the called function transfers the control back to the calling function or the caller. Now return statement is an unconditional control transfer statement. That is, it transfers the control from the called function to the back to the caller unconditionally. That is, no condition is checked, like the conditional statements in C and C++, like if, else, nested ifs, or if else if ladder, or switch case, where there is the condition, and based on the condition the control is transferred. But in case of return statements, we don't have any condition, so the return statements are put under unconditional control transfer statements. The function can have multiple return statements, as I told you already. Return statements can be placed anywhere in the function body. It's not that necessary that the return statement will be placed at the end. It can be placed anywhere in the function body. Now, the syntax of the return statement is return, then expression. Now this expression can be an arithmetic expression, logical expression, expression. It can be a value, it can be a variable, etc. Whatever are the possibilities that we have discussed for the expression. Normally it's a value or a variable. Okay. Now the golden rule is that the type of value returned by the function in the return statement should match with the return value and the data type of the variable in the calling function or the caller in which the function called returns the value. That is, in the called function, once we call a function which returns a value, and once we assign it to the variable, the data type of the variable in which the function value is assigned should be seen as the return type, okay, of the function. If it is not same, then it may lead to problems. We can discuss that later. Now, function return types. A function can equally return a reference variable. This is a special case. In this method, the functions that return a reference is used in operator overloading. We have to discuss that technique, but right now you remember a function can return a reference variable. We have seen how we can pass a reference variable to a function, and we will see today how we can return a reference variable from the function. This is a very important technique, and it can lead to cascade of member function calls. This we'll see in detail in operator overloading. Lastly, the function can be made to return multiple values. This is not the formal method of returning a value from a function. This is somewhat what we call as the informal method. Formal method is that we mention the return type of a function and that is linked with the return statement. In the return statement we mention a value and that is returned by the function, or that value is returned by the function. But it is possible that function can return multiple values by using global variables. Now we can also make function to return multiple values by passing the arguments by reference or by passing the arguments by address. Okay, so I have not mentioned that, so you take it here. I have written that, but I have not mentioned it. You take it that the function can be made to return multiple values by passing the arguments with reference or by passing with address. We have already discussed that, and there are videos here that can guide you. Now let us go into the IDE and do this practically. I declare a function x. Okay. It returns a value of type integer, say int. I am simply showing you how we can use a return statement and what is the link of or association of a return statement with the function return type and with the variable to which we are assigning a value in the calling function. Now let me create a variable here, int a. This is a local variable of x equal to 90. Okay. Now I can say, suppose I say return a. Now since I am mentioning the name of a variable a in the return statement, so the data type of a is int. So in the return type, that is in the function declarator, I am writing the return type as int. So a's return type, a's data type, that is int, should match with the return type of the function. And once again, if I have suppose variable s, now in the s I am assigning the value returned by the x. Okay. Since x does not have any actual formal arguments, so I am not passing any actual arguments. This function is simply to show you what is the return statement, what is the return type of a function, and what is the relation of the return value with the calling function. Now in this case the calling function is main, since it is calling x. Now once the x is called, it is returning a value that is stored in a. The data type of a is int, so the return type of the function, which is mentioned in the first line of the function or function declarator, is int. Now we assign the value that is returned in the main. The function always returns a value at the point of call. Now what is the point of call? We say s is equal to x and we call x. Now x is being called at the place, at this place in the assignment statement on the RHS side. Now x will return a value in case it is returning a value. So in this case it is returning an integer value. This integer value will be returned at the place, that is at the point of call. So simply you can write the return value here. So the expression will become something like this. It will become actually like this: s is equal to 90. Why 90? Because x is returning a and a has a value 90 and the function returns a value at a point of call, so that this statement actually becomes s is equal to 90. 90 is a value that is returned at the point of call. Okay. Now who is the calling function? Main. He is assigning some task to the x. X is performing that task and it is returning a value 90. Okay. That 90 is stored in s. So we can see by executing this. Now main is calling x, the control is transferred to x, we have a variable a in x. Now that variable is mentioned in the return statement. Okay. Now, so the data type of a is int. So 90 is returned at a point of call in the main once we return from the x. See, and if we watch control, if we watch the value of what you call s, we will see that it has got a value 90. How did value 90 come into s? Because this value was returned by the function x, and that value was assigned to s. Okay, so whatever value is returned by the function, that will be replaced at the point of call of a function, and accordingly that value will be assigned to the variable on the LHS side, in this case which is s. Now if suppose this function had another variable, say character k equal to constant. Now instead of returning the a, let us suppose the function returns a k, that is the value stored in k. So in this case the return type will be modified to char, and the variable in which I am assigning the value returned by the function in the calling function, that is main, should be modified to char. So there should be a match at three places. First, the data type of k is char should match with the return type of the function, and it should match with the data type of the variable in which we are assigning the return value. Let us execute this function once more, and now this time I am making call to x. Okay, now k is assigned the value o, and k is returned from the function. Now once k is returned from the function, the value is assigned to the s in the calling function, that is main. Okay. So this time this function is returning the character data. Same can be true of float and double data type. Now we have seen how the function returns a integer data type and a character data type. So the primitive variables of float and double can be also returned from the function. Okay, you have to use the same method. I won't be showing that I'm giving you as an exercise. Okay, now this was so far as primitive data types are concerned. Now the function can also return an object, that is a user defined data type. In that case we have to first create a class x, let us keep two variables in it, int a and int b. These are the two data members of my class. I'll simply keep class without member functions. Okay, so you can later on extend it, but let me name the class as example because I have already named the function as x. Okay, now this is the class, and I can create an object from this class anywhere where I need them. Okay, let me create an object inside the x. Now example say o. Now example is a user defined data type that has been created by me, that is a programmer, and I have created the object of type class. So the data type here is user defined type, that is example. Now in the return statement, if I say return o, what I am returning here is an object. Since I am returning an object of type example, in the return type I will mention the same data type as is the data type of the o, which is the example, that is the user defined data type. So this is the This is the function that is now returning an object. Now in case the function is returning an object, we are assigning that object to S. Now the data type of S should be of the same type as O. Okay, so that is example. That is, we receive the return value in the S. Okay, now the function X is returning an object, and that object has been assigned to S, and the data type of S is also example. That is the three things matched. That is the data type of S, in which I am assigning the return value, the data type of O, that is the example, and what you call and the return type. The data type of O in the return statement, that is matching with the return type of the function, and that is matching with the variable in which I am assigning the answer. Okay, let us see whether this works. Let us compile. Okay, this is working. Now I'm calling X, the main is calling X, it is returning O, and the O is assigned to S. Okay, so this is how we return the objects from the function. Okay, this is how we return user defined data type. Similarly, a structure variable can be returned from the function. I can say struct and say example2, then I can keep two members in it. Okay, int X and int Y. Okay, now I can create a variable, structure variable of type X in example2 in X, say S1. The return type, I return S1 from a function. Okay, so the return type of the S should be X, return type in the X should be example2. After mentioning the return type of the X, that is example2, since it is returning S1 and the data type of S1 is example2, and that is a user defined data type, because structures and classes are used to create user defined data types. Now it is returning the example2, that is the function X is returning the example2, and at the point of call of X it is assigned to S, but S is of type example, so I need to modify the data type of S to example2. Now you can see this is how the function can be made to return a structured variable. So the function can return primitive data types, the function can return user defined data types, and the function can even return the integer pointer here P. If I say return P, okay, now the function is returning a pointer, and that pointer contains the address. Okay, you have to mention the return type as, if you mention it as an int, because the data type of the P is int, but then the function will have a confusion whether the return value is the integer or a pointer. In that case, we use a star here again to designate that we are returning a pointer. Okay, now since the function is returning a pointer, the data type of S should be of the same type. I can create an int, but since P is a pointer, so S should be of type pointer. Okay, now let us see whether that works. Yes, it is working. So the function is returning P, that is the pointer, and it is accepted in the S, that is of same type as. So it is a general rule that the return type of the variable, in this case which is a pointer, should match with the function return type which is mentioned in the first line, and it should match with the type of the variable which we are assigning the return value. Now this was how the function can return a pointer. Okay. Now let us see the other possibilities for the return statement. Okay. By now we have seen that function returned the data that was present in the variables, or variables were of primitive data type, or the variables were of user defined data types, that is objects and structure variables, and the variables can be of type what we call derived data types, that is pointers. So we have seen the function can return user defined data types, derived data types, and primitive data types. Among derived data types, I have not shown you arrays, because arrays, if you once I will be uploading its videos, arrays are passed by address, so I need not to we need not to return them, because they will be automatically returned. That is, whatever changes you make in the calling function in an array, that will be reflected in the call function automatically, since they are passed by address. We have seen that in case of the variables, if they are passed by address, whatever changes you make to those variables in the calling function, they will be reflected in the call function. So now let us see other possibilities for the return statement. Now let us suppose function returns a value, say suppose 10. Now I am returning the constants from the function. So if the function returns a 10, I have to see the data type of this number, that is 10, that is an integer. So now it is returning an integer, and it should be assigned in an integer. Okay, if I compile it, you see, and run it, you can see I am compiling. Now I am running it. I am calling a function. Now once I am returning the s as a value 10. Okay, so this is how the function can return a constant. In the return statement, initially we showed how we use a variable. Now I am showing constants. Now suppose I return 10.6. In that case, I should return it in either float or double, depending upon the range of the constants. If the constants lie in the range of float, you can use float, and if the constants lie in the range of double, you can use double. So since it's a, I can use double. Now, so in the return statement, if I am returning a constant, I have to see the data type of that constant, and accordingly I have to use the return type in the declarator, and accordingly I have to use the return type in which I am assigning. Okay. If you see here, s will be assigned 10.6. okay, that is in the main, the s has the assumed the value 10.6 because x is returning 10.6. Now let the function return a character constant o. In the function returns a character constant, then in that case we have to mention char here. Okay, so we can again modify the type of s, that should be modified to char. Okay, now if you run it, you will see function returns a character constant o, and that constant will be assigned in the calling function to a variable in which we are assigning the return value of the function call. This is clear. So in the return statement, you can mention the constants, you can mention the variable names. Variable names can be of any data type, that is, they can be of primitive data type, user defined data type, and what we call derived data type, and accordingly you have to mention the return type in a function. So this is important concept. Now there is one more possibility, that in the return statement we can use expressions like suppose 2 plus 3 into 2. Now what will happen in this case? The function that returns an expression, that expression will be evaluated using the rules of what we call precedence, associativity, and if you have done typecasting, that will be also implemented, and ultimately after evaluation, whatever value that will be generated by the expression, that will be returned by the function. Now in this case, since multiplication has a higher precedence than addition, we can 3 into 2 will be done first, that is 6, and 6 will be added to 2, and we will get an answer of 8, and that 8 will be returned by the function. Again you can see, now I have to modify here, because the value generated is of type int, so I have to modify the data type of s. I can again re-execute it. See here, I am calling x is returning the value that is computed by the function. So again, if you see, s has the value 8, because 3 into 2 is 6, and if you see in wash window, and 6 plus 2 is 8. So we can use the return statements, we can use the arithmetic expressions, logical expressions, conditional expressions, and even mixed mode expressions. So you can write expressions as well as in the return statement. But the values generated by those what we call expressions, we should know what is the data type of that value, and that data type has to be mentioned in the return type. Again, I had made a mistake here. I had to mention the return type in this case as integer, because this expression was generating an integer, and that integer I had to mention here, and again the value I was assigning to the s, that I mentioned as integer. So the function can return the expression, function can return a constant, or function can return a variable. Now these expressions can also contain variables, as we have the variables, the expressions can have constants as well as variables, no problem with that. So this was so far as return. Now the function can have multiple return statements. This is another important point. And return statement can be placed anywhere. Suppose we have got int a or int q equal to 90. Okay. Now I have got another return statement, say q. Now this function has got two return statements. Okay. And in between, if I put some processing steps like q is equal to q plus suppose 10. Let us see what will happen in this case. In this case, what happens, the moment the return statement is executed by the processor, the control is transferred back. It depends on the first return statement that is executed by the processor, and the control will be transferred back to the calling function. Let us see. In this case, again, main is the calling function, s is the call function. So the caller, that is main, is calling the x. Now once it is calling the x, the statements of x will be executed one by one. The moment the return statement will be encountered, the control will be transferred back to the calling function. And if there are statements after the return statement, they won't be executed. So this is the scenario when the function has got multiple return statements. The moment a return statement is encountered, control is transferred back to the caller. Since the control is transferred the moment the return statement is executed, so return is an unconditional control transfer statement, because it is not based on any condition. Now you see, I am saying return q. Now if you see, the control will be transferred immediately to the main. The next statement, that is q is equal to q plus 10, and the next statement after that won't be executed. So the moment the first return statement is executed, the control is transferred back to the main, and if you see, the control has been transferred out, and s has the value 90 because q was initialized to 90. Now if this return statement, that is the first return statement, and the second return statement would have both executed, then in that case q would have been also implemented, but that's not the case. It is always the moment you get the first return statement, that is executed, and the control is transferred back to the caller. Whatever steps that have been executed in the function, up to the first return statement that is encountered, only their effects are seen, and the remaining statements that follow the return statement are not executed. Okay. So the function can contain multiple return statements. This was one more scenario, so far as the return values are concerned. Now we can have one more exercise in which a function can return a reference. Now in that case, the variable should have been passed to the function by the reference. So this is the typical scenario. Now see here, I have got a variable h. I want to pass it by reference. I mention it in the actual argument, and in the formal argument, since h is of type integer, I say int, say d. I am receiving h in d. If I int d, if I do like this, I am receiving h by value, because the copy of h will be assigned to the copy into d. That's whatever is the value of h. Now let me initialize h also. Here let h be 90. Okay. Now 90 will be passed to the d. Okay. But I want to pass h by reference, so I have to make a slight modification, which we have discussed in parameter passing. Once we pass by reference, we have to place an ampersand sign here. Okay. Now argument h has been passed by reference. So in in return by reference, you should have passed one of the arguments by reference. Okay. Now, how do you return this? You can return the d. Suppose return d. Now, d is not a variable; it is a reference. So you have to mention the return type here as int ampersand. So that is the difference. Once you return by the reference, you are actually returning some reference variable, since d is a reference variable. Okay, so we are using the what you call d in the return statement. Since d is not an ordinary variable, so it's a reference, so we have to return the reference. We cannot mention int only, because we use that for those variables which are not reference type and have integer data type. Since d is a reference of type integer, so we have to designate that by a ampersand. Okay. Now let us see how this call executes. Okay. Now I am passing h, the value of h. It's not the value of h. H has another name now, d, and we are returning the d to the to the calling function, that is main. The value of d is 90, because h is 90. We have not made any changes in the x. So if you see, s has been assigned value 90. Okay. If you make changes also, that is also possible. We can say d equal to say 89. Okay. Now once I call, if you see, I am passing h by reference. It has a second name d. Now I am changing d to 89. Let me watch h also. Okay. Once I return. Now once I return, since I have changed d to 89 and d is the second name of the h, you will see the h has also changed. In the calling function, that is main, the h had the value of 90, but it is now 89. Why it has changed? Because we passed h by reference, and since we are returning by the reference, so we are actually returning the value of h here or d here, that is assigned to s, because we are returning d. Okay. Now let us see the beauty of this. By now we have never seen the function cannot, in the assignment statement, if you remember, the syntax is that variable equal to expression, and that expression can be sometimes a function call, as we have in this case. S is equal to a function call and followed by a terminator. But in case of function returning by reference, we can also write a statement like this: x of h, okay, equal to, let me place another variable l equal to 12 here, x of h equal to l. Okay. You might not have seen statement like this so far, because whenever we made a function call, we put it on the right hand side of the assignment statement, and that's the rule. But those functions which are returning by reference, we can put their call on the LHS of the assignment statement. Okay. Now let us see what happens in this case. Let me put the first call into the comments. Okay. Now once I call from the main, I am calling x of h. Okay, and the reference of h is d, and d is assigned 89. Now I am returning the d. Now since I am using the function call on the LHS side, so actually x of h is same as saying h, because d is the reference of h, and so we say actually this statement can be translated as x of h. Since it returns a reference of h, that is d, we can say it is same as h equal to l. Now if the statement is same as h equal to l, the value of l will be assigned to the h, and the value of l was 12. If you see in the watch window, h is now having 12. But the thing here is that is worth mentioning is that we can have function call on the left hand side of the assignment statement, and only when the function returns by a reference. You can also return an object by reference. How do you do? We have to create an object example. We have a class example already that has been created. Say we have an object O, and if we remember, created a class example, we are passing the object O now by reference. Okay, I can use this statement first. Okay, S is equal to object O. Since I am passing object O, the rule is that I have already shown you that once we pass object, we should accept it in an object. The formal parameter should be of the same data type, that is example. Okay, so if we pass the object O of type example, we are receiving it in a reference of type example. Okay, then we can, let us remove the statement window, and if I am returning D, I am returning a reference of the object O, that is the second name of the object O. Okay, now another important point is that the data type of S should be of type example now. Okay, because we are assigning it to S, and S cannot be an integer because the value that is returned by the function X is D, and D is a reference of an object of the class example. So the S should be also of type example. Okay, this is how we can make functions return an object by reference. Now again, in the return type, since I am returning D and D is a reference of type example, I have to first change the data type of into example, because the data type of D is example, and since it's a reference, I am mentioning ampersand. This is how we can return objects by reference. Now we have an object D, reference D of the object O. D is not an object, it's actually a reference, that is the second name of O, and that has been returned by the function. So the return type of the function is mentioned as example, after that ampersand sign to designate that it is returning a reference, not a normal variable. Now once the function is returning a reference, we can assign it to the variable on LHS, which is also of same data type as what you call O. Okay, now we can again call a function. That second method of calling can be also used here, that is we can call a function, we can make a function call on the LHS of the assignment statement, and since we are assigning L to this, L's data type should be same as what you call as the reference. So we have to change the L's data type to example. Okay, once we modify it, okay, you can see it here. Now I am calling a function and it is returning by reference, and since it is returning by the reference, in this case what will happen, the members of the object L will be assigned to the members of the object O. Okay, their corresponding values. Okay, if Now this is how the functions that return an object by reference. Similarly, structure variable can be also returned by a reference. But the important thing here is that once the function is returning by a reference, whether it is returning a primitive data type, whether it is returning a user-defined data type, or whether it is returning a pointer, or reference of a pointer. In that case, we can make a call, we can place the function call on the RHS as well as LHS of the assignment statement. And since we can place a function call on the LHS of the statement, you will see in operator overloading, this can be used to make cascading calls. Once I upload a video on operator overloading, it will be clear at that time. So this was all about functions returning a value. Let us go back and see what we have done so far. Now we have seen that functions can be of two types based on return values: functions with return values and functions which do not return a value. These functions are called void functions. So in void functions, we won't be putting any return statements, and the return type will be mentioned as void. The function can return the values of different data types. We have seen the function can return the values of primitive data types, the function can return the values of user-defined data types, and function can return the values of derived data types. Now return values are always specified in the return statement. We have also seen that the function can contain multiple return statements. We have seen that we can place multiple returns, but the first return statement that is executed transfers the control from the called function to the calling function or the caller. This we have seen. Return is an unconditional control transfer statement. We have also studied that and seen in the ID. Yes, this is true. Now, the function can contain multiple return statements. Again, I have discussed that. Return statements are placed anywhere in the function body. We have seen we can place return anywhere, not necessarily at the end. And if you see in the books, mostly you will have functions that have the return statement in the end, but it's not a case always. We can place return statement anywhere. Now the golden rule which we have seen today, that the type of the value returned by the function, that is the value that is returned by the function in the return statement, should match with the return value and the data type of the variable in the calling function or the caller in which the function call returns the value. This is the most important thing. Okay. Now the function can return a reference value. We have seen that in the end. In this method of using the reference, we can use it in the operator overloading to make the cascade of to form a cascade of member function calls. Yes, this is true. We'll see once we'll study operator overloading how that can be implemented. Lastly, function can contain multiple function can return multiple values. This we have already seen with global variables and or by passing the parameters by reference or by address. I have not mentioned address here, so you should take that. That's important. So function can be made to return multiple values if we pass it by pass the arguments, that is actual arguments, by address or by reference or by using global variables. This was all about the function return types. I hope you have enjoyed today's video. Thank you.